Okay, so what do we have and what have we learned so far? We've learned that a mean, an overall mean, can be represented as a mean of means, or a weighted average, here are the weights, of group means. So we've got G groups, each with their individual mean, and we can combine all of those together, and we come up with the overall mean. Now, each of these PJs, as you've seen, are each greater than or equal to 0, and they sum up to 1. Oh, and in fact, the example you looked at with ranking of hospitals, the US News World Report every year comes out with the ranking of hospitals, and this is exactly what they do. They consider various subcategories, and then they get points from each subcategory, and then they sum it up together, and they come up with an overall category. And they must be doing something right, because here they are for this year, and there are 2 Harvard hospitals in the top 10, including the top 1 actually, and here's my alma mater, Johns Hopkins. So they really must be doing something right. But that is how you come up with a composite average. So now let's look and see what in fact has been happening with the age-specific mortality rates. Let's go back to that, and then before we come to any conclusions, here they are. I've drawn them for you, and here's the overall. I've put the overall one in the middle here, and you can see it's going down gently, 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 but the components are going down at different speeds. Here's the less than 1, of course, is the fastest, and even the 1 to 4 is also very fast. That's this one. But there they are by age group. Before we leave this, I thought you'd be interested. I took it back to 1900 to show you this because I thought you'd be interested in this. And what is that? Well, that's the 1918 flu epidemic. And what you see those spikes, but the spikes are of different sizes, and there are no spikes up here. So only a certain part of the population was affected. Anyway, you can see all that from this. But why did we do this? Well, because this is why you did the exercise that said as things improve, we get older. And as a result, we get penalized in the overall rate if that were to happen. And in fact, if we look at the composition of the US population in 1940, that's the blue things, that's the blue bars in 1940 in the various age groups, and compare that to 2000, we see that in the early age groups, the blues are above the reds. In the later one, the reds are above the blues. So what does that mean? That means we're getting older. That means the population is getting older. Now, it's a tiny little bit unfair because the two populations don't quite look the same. They almost look the same, but what's happening is this is a little bit too big and that's a little bit too big. And those are the baby boomers. So there are our baby boomers, born after the Second World War. But if those were a little bit lower, then the reds would have a similar shape in terms of sort of going up and then coming down. The reds and the blues would look kind of similar, except that the reds, are getting older. So we are getting older. So then the question is, what weights should we use? Let's standardize and use a set of standardized weights. So for example, if we go back to our crude death rate, if we were to use the 2000 weights, in 2000 we're older than we were in 1935. So if we look at the age-specific rates from 1935, but apply them to an older population, because if we applied those to the 2000 population, use the weights from 2000, we would get a number up here somewhere. Same with the 1940, we would get a number up there. In 2000, we'd get the same number. So there'd be a crossover in 2000, because it's that if we zero in on using the 2000 standard. But we would get something like this. In fact, here it is. Here is the actual numbers. So this is what is called the age-adjusted death rate. It's adjusted to having a population that looks like the year 2000. The population in the year 2000. It has that age distribution. So if we take our weighted average with the weights given us by the population in the year 2000, that's exactly how that curve is calculated. That is what is called an age-adjusted death rate. So now we can make comparisons from year to year without worrying about the effect of the composition changing. In summary, what we've done is we've gone from looking at the number of deaths to the crude death rate by just dividing by the population size, by making a construct. So this is a construct, so be careful, this is a construct, which requires us deciding, making a judgment, what population to use to give us the weights. But once we do that, then we get a purer comparison. So when comparing two composite means, make sure we are comparing likes. If the composition changes, then the comparison of means is less clear and there's more confounding going on. We're confounding things with, for example, we're not just comparing rates, we're confounding it with the age of the population. So we're confounding with the age of the population. This is exactly what goes on with index numbers. So if you're thinking of the consumer price index or the things like that, similar things, that's exactly how these things are calculated. These are the standardization methods.